In 11.5 notes, we're going to check out some extraneous solutions. We've done extraneous solutions before when we had square root problems with equations. We tried taking our answers, for example, like x equals 7, and plugging them into the original problem to see if it was fine or to see if it caused the problem to completely mess up, because we could not take square roots of negative numbers. So when are fractions okay and when are fractions not okay, or when it's a no way problem? Okay, so it is okay for a fraction to be 0 over a number. That is okay. 0 over a number means 0 divided by something. If you have 0 of something and you try and divide it up all over between all of your friends, you get 0, and that's fine. The second example, though, when is it not okay to have 0 in a fraction? And that's when the denominator is 0. So if it's a number over 0 is no. It says no in it. It is an undefined problem. Okay? It's like if I ordered a certain number of pizzas, like 7 pizzas, but 0 people were there to eat pizza, then what happens to all of the pizza? If you put it in one pile, that's dividing by 1, but you're trying to put it in 0 piles. That's impossible. Okay, so this means, this no way example is that an extraneous solution. Okay, so extraneous solutions happen when you plug in an answer and you get 0 in the denominator. Zero in the numerator is fine, 0 in the denominator is not fine. Okay. If our whole problem only has an extraneous solution and there's not another solution, okay, then that means that there is no solution for the whole problem. Okay. There are examples where you could get 2 different solutions and you plug one of them in and it's okay, and plug the other one in and it's a no way. So the one that does work would be the solution. But if there's only extraneous solutions, that means there's no solutions for the whole thing. All right, let's do a couple quick examples. Let's take a 7 and plug it in everywhere you see an x. So the top of the fraction is going to say 7 minus 5. The bottom of the fraction is going to be 7 minus 7. So this is going to be 2 over 0. Can you divide by 0? No. No way. So x is not allowed to equal 7. Okay, you really only have to try it in the denominator. Okay, let's do the next one. Let's plug in 2 everywhere we see an x. So 2 plus 6 over 2 plus 2. That is 8 over 4. Not dividing by a 0, so this is okay. All right, so x equals 2 is allowed to be a solution. All right. The rest of our examples, numbers 3 through 8, all we're really going to do is see what numbers would make our denominators get a 0. So what is x not allowed to equal? Okay, so we're going to take this first fraction and just say x minus 3 cannot equal 0 because denominators are not allowed to equal 0. Second fraction, same thing. X minus 10 is not allowed to equal 0. And then these are just usually one-step equations or two-step equations. Let's solve. Plus 3, plus 3. So x is not allowed to equal 3. Second one, add 10, add 10. X is not allowed to equal 10. So 3 and 10 are the extraneous solutions. Number 4, set each denominator equal to 0. 19 does not equal 0. X plus 4 does not equal 0. So on that first part of this where it says 19 does not equal 0, there's no x in that denominator. So you're not going to find an extraneous solution when there's no x in the denominator. So this one doesn't matter. That means we really didn't even have to write that one out. It was impossible to find an extraneous solution there. Second one, subtract 4, x cannot equal negative 4. So -4 would be an extraneous solution. Number 5. Okay. X plus 3 does not equal 0. 2x minus 12 does not equal 0. Subtract 3, so x does not equal -3. Second problem, it is a two-step equation. So add 12, 2x does not equal 12. Divide by 2, x does not equal 6. Okay, so we did have to do 2 steps because there's a coefficient on that x. Number 6, first equation. Notice we're only caring about the denominators, and that's because in the original problems, it doesn't matter, like in the original notes up here, it was okay when the numerator was 0. That was totally fine. All right, back to number 6. Hey, look, that first equation just says x is not allowed to equal 0. X is by itself, so that means that 0 is a solution that does not work. It's extraneous. Second one, subtract 8. X does not equal -8. Okay. Number 7 and number 8 are going to be easier to solve for extraneous solutions if you factor the denominator. So let's try factoring this x squared minus x minus 20. This is a shortcut problem. We need negative for the big number, opposite sign for the small number. Looks like +4 and -5. So let's set all of the factors not equal to 0 in their own little equations. So x minus 6 does not equal 0. X plus 4 does not equal 0. X minus 5 does not equal 0. You might have noticed on these one-step equations that we just end up getting the opposite number. So x is not allowed to equal 6. X is not allowed to equal -4. X is not allowed to equal +5. And last one. We do have an x squared in this problem as well, so we will have to factor this guy. X squared minus 9, that is a difference of squares. So that'll be x and x, 1 plus, 1 minus, and then the square root of 9 is 3. So our little equations look like x plus 3 does not equal 0, x plus 3 does not equal 0, x minus 3 does not equal 0, and x minus 3 does not equal 0. You notice that 2 of those equations are the same. So this one and this one are the same, so we don't have to do it twice. This one and this one are the same, so we don't have to do it twice. Okay. If we subtract 3 from both sides on this guy, we end up with x does not equal -3. Add 3 to both sides on this one, x does not equal +3. The end.